Okay, welcome back. Actually, for this chapter that involves intercept and slope dummies, it is possible to conduct hypothesis testing. So in the study guide, I have done two questions, 7 and 8, and here in this video, I would do question 7. Okay, so salary explained by years of educational attainment, the male intercept dummy, and then the education year times male slope dummy. So currently in the sample regression function, we use both intercept dummy and slope dummy. Okay. Sample size is 34. Okay, so let me write that down. Small n equals 34. K is equal to 1, 2, 3, 4. 4 parameters. Therefore, degrees of freedom is 34. First one is quite easy to derive the sample regression function for the male student, because if someone is really male, then the male intercept dummy is 1. And then for the slope dummy, education year times male, it will give you education year times 1. Then you add the two constant values together, 100 something plus 10.25, that gives you 110.81. And then the slope would be 30.15 edged year plus 10.77 edged year. That gives you 40.92 edged year. So this is 7.1. And then 7.2, derive the sample regression function for the female. Then you can see the male dummy intercept dummy equals 0. And then for the slope dummy, it will give you 10 times edged year times 0. So these two terms falls away. This is why for the female, you will have a smaller constant compared with the male, and then a flatter slope. Okay. And then actually the graphical illustration for the sample regression function is as follows. The female sample regression function has a smaller constant and flatter slope. Okay, but now remember, as we have done in ECO311 and even chapter 8 of ECO311, always remember the reason why we conduct hypothesis testing is if something happens in the sample regression function, there is no guarantee the same thing would happen in the population regression function. This is why we would do 7.3. We want to test the intercept dummy. In the PRF, is it equal to or greater than 0 at alpha equals 1%? So in other words, I want to know would the intercept dummy feature in the PRF. Okay, so let's do the 5-step procedure. Step 1. Now I'm testing the true B3. New hypothesis is B3 equals 0. Alternative hypothesis is B3 greater than 0. Computer t-stat. B3 hat 10.25 minus the hypothesized B3 value, which is 0, divided by standard error of B3 hat 4.77. Then this is your computed t-stats, 2.1489. And if you use the t-table, I'm not going to show you the t-table anymore. You have enough experience. Critical t-statistic, one-sided, there shouldn't be an S here. One-sided right-tail test, alpha 1%, degrees of freedom 34. Critical t-stat is 2.457. And since the computer t-stat is smaller than the critical t-stat, the new hypothesis is not rejected. So it actually means in the PRF, most likely the new hypothesis would happen, meaning B3 is 0. So if B3 is 0, then it actually means the male intercept would not feature. Okay, so let's look at step 5. So the new hypothesis will take place. That is, if the years of education is 0 in both genders on average, salary is exactly the same in both genders in the PRF. So the conclusion is, although we use the intercept dummy, the male dummy in the sample regression function, from this hypothesis testing result, the conclusion is that in the PRF, there is no need to include the male intercept dummy, meaning in the PRF, there is no gender difference in the constant. Okay, happy with that? Then we can look at question 7.4. Now I want to test the slope dummy. Currently in the sample regression function, the slope dummy is positive. So I want to know what is going to happen in the PRF. So new hypothesis, B4, the true B4 is 0 in the PRF. Alternative hypothesis, B4 is greater than 0. Computed t-stat B4 hat 10.77 minus the hypothesized B4 value, which is 0, divided by standard error of B4 hat 3.89. This is my computed t-stat, 2.7 something. And then the critical t-stat 2.457, and this time the computed t-stat is greater than the critical t-stat. So we reject the new hypothesis, meaning the alternative hypothesis is more likely to happen. Then it means there is gender difference in the slope parameter, meaning the alternative hypothesis would take place. That is, if the years of education increases by 1, on average, salary would increase in both gender, but such an increase is greater in the male, meaning the slope dummy, while it features in the sample regression function, from this hypothesis testing result, the conclusion is that the slope dummy is also needed in the PRF. So that brings us to the last part, the graphical sketch. Okay, so for the PRF, we don't need intercept dummy, so there is no gender difference in the constant, but there is gender difference in the slope parameter. So the male line is steeper. Okay. So this is the ultimate reminder message. Always keep in mind, if something happens in the SRF, there is no guarantee that it would also happen in the PRF. This is exactly why we need to conduct hypothesis testing. Okay. And then next, there is a very short section on the slide. It is called interaction dummy. It is actually called the product of two dummies, but the two dummies are derived from two different categorical variables. And the impact of interaction dummy is similar to the intercept dummy you learned earlier. It will cause the constant to be different. So this is the first example. Male dummy times white dummy. It is correct as an interaction dummy because the male dummy is derived from gender. The white dummy is derived from ethnicity. Example 2, it makes sense. This is an interaction dummy because male dummy is derived from gender. Western Cape dummy is derived from province. Okay, and then let's say the last bullet. This is clearly not an interaction dummy. Western Cape dummy times Eastern Cape dummy. Both are derived from the same categorical variable, which is province. But it is impossible for someone to live in Western Cape and Eastern Cape at exactly the same time. It is impossible. It may be possible the person purchased properties at both provinces, but the person can only appear at one place at the same time. So keep in mind, interaction dummy, this is the key requirement. It is derived from two different qualitative categorical variables. And we count this whole product as one explanatory variable. And then there is a example here, question 5, okay? Clearly, you see two interaction dummies, male times color and then male times white. And then you see the three normal intercept dummies, color, white, and male. And then you have a continuous variable, equal 1 mark. So these are the factors influencing equal 2 mark. And I'm not going to go through all the answers because you have the answers on the study guide. So upon doing 5.1 to 5.7, you are going to realize that the interaction dummy would cause the constant to differ, but it has no impact on the slope parameter. And then at the end of the study guide, you would see this summary table. So let me stop for 1 minute for you to go through that. Okay. And then for the last part, the piecewise linear regression model. So you suspect that from a particular x value onwards, we call it x asterisk, there is a change of the slope parameter. For this module, we focus on that the slope becomes steeper from x threshold. So you are going to have an abrupt change of the slope parameter. You have to derive the regression equation, and then you have to do a graphical sketch. In fact, there will be two regressions you have to derive. What happens at this portion before smaller than x threshold, and then from x threshold onwards, a steeper regression. slope parameter. And again, a reminder, piecewise linear regression is for cross-sectional data regression. Okay, and then I don't think I need this slide. And then the equations from this slide, it is a bit confusing when you look at it for the first time. So in order to fully understand this equation, let's better do one question. Okay, so which is question 9. Okay. Second year mark is explained by first year's performance plus this slope and then bracket the ECO1 mark minus the threshold 60. So I'm going to distinct times the good dummy. Okay, good student dummy. So the threshold x asterisk is 60. So this good dummy equals 1 if the ECO1 mark is at least 60, then the good dummy equals 1. It means a good student. But for someone who is a weak student, it means the first year ECO mark is less than 60, then the good dummy equals 0. So this is my overall regression. And from this overall regression, I want to derive two sub-regressions or regression equations for the two groups of students, one for each group. So the regression equation for the weak student, it means the good dummy equals 0. It is equal to minus 30 something plus this whole thing 0.97 something times ECO1 mark plus 1.5314 bracket ECO1 marks minus 60 times the good dummy equals 0. Remember, we are dealing with the first group, a weaker student. So this whole thing falls away because of the 0. So for the weaker student, the regression is as simple as this. Minus 30, so this is the graphical sketch, and then the slope is flatter, 0.9786. And then for the graphical sketch, I must label the x and y axis variable, and then the dotted vertical line, the threshold x asterisk 60. So I'm done halfway through with the graphical sketch already. And then the regression equation for the strong students, it means at least 60 in first year's economics. So the good dummy equals 1. Okay, and then you can work around, you need to do some expansion, and then you get this answer. Steeper slope. Okay, see the comparison, steeper slope 2.51 something. Then it means for these good students who obtain at least 60% or C symbol in economics 1, the impact of good first year's performance would be greater when it comes to their second year performance. And it actually means those who perform better in first years, they would also perform much better in second year, let's say economics. And then the slope parameter is steeper, 2.5103, but then the constant is smaller. All you have to do is that for this steeper line, you extend it by means of dotted line until it touches the y-axis, and then you put this constant minus 122.3220. And then if you draw this graphical sketch, you are going to get full marks. So let me leave it for another 30 seconds. And let me clearly show you the two regressions. Otherwise, we are done with chapter 9. Then the last 4 chapters will be the really, really difficult stuff. Chapter 10 on multicollinearity, Chapter 11, heteroskedasticity, Chapter 12, autocorrelation, and Chapter 13 on model specification criteria, which deals with issues like using the wrong functional form, underfitting, and overfitting.